Good morning, students. So now we have, as you already know, that we are doing with this chapter recursion, and we have done few things about this. Now this is an important and obviously an interesting example in recursion, which is known as Tower of Hanoi. Now this is a simple children's toy where some discs were there of varying diameters and three pegs were there, A, B and C. Now the task is to move all the discs from peg A to peg C using B as the intermediary peg. Okay, but the condition is there, you can move only one disc at a time, and the disc with bigger diameter is always at the bottom. Okay, that means the disc with smaller diameter is always at the top. Okay, now this problem comes from history. That is, monks of Vietnam were asked to carry 64 gold discs from one tower to another. Each disc is of different size. Now the disc is placed on one of the three stacks, but no disc can be placed on top of the smaller disc. That is the condition. Now the easiest solution for this is the recursive one. The key of the solution is to notice that to move any disk, we must first move the smaller disk of it. Thus, a recursive definition. Another way of looking at it is just like this. If we had a method to move the top three disks from the middle position, we could pick the biggest disk in its place. All we need to do something, we have this method and then call it. See here, move disk 1. Suppose you are having only one disk, so move disk 1 from the start tower to the end tower. Now if you have two disks, then move the smaller disk from the start tower to the intermediate tower and move larger disk from the intermediate tower to the final tower. Then move the smaller disk from the intermediate tower to the final tower, and we are done. Now if three disks are there, we can do like this. You can see the video here. I am showing you, just a minute. ABC were three pegs. That is moving from A to C using B as the intermediate step. Then moving now I am moving from B to C using A as the intermediary. Okay, so now you have seen that how we are moving three disks from peg A to peg C. That means solve the problem for n minus 1 disk using the intermediate tower instead of the final tower. Okay. Then you have to move the biggest disk from the start tower to the final tower, as we have done in the example. You can see that animation in the by skipping the video. Okay. Then again solve the problem for n minus 1 disk, but use this intermediate tower instead of the start tower. Okay. Now here you have to assume something, that is A is the from peg, B is the auxiliary peg, and C is the to peg. Okay. Now how I am doing? Moving from A to all the disk to B, where C is my auxiliary peg. Then I am moving from B to C, means that is, first of all I am moving from peg to aux peg. Okay. Next I am moving from peg to peg, that is a single disk in from peg I am moving. Then moving all the disk from aux peg to peg. Okay. Now here is the algorithm for doing this. You just understand the algorithm, then the program is written there. If you can understand the algorithm, you will be able to write the program, and this program can function for any type of disk, means 5, 6, 7, 8, whatever it is. See, from at first I have to move from peg to aux peg using to peg as the auxiliary disk. Okay. Now what is my condition? If n disk equal to 1, then move from peg to peg. Okay. Otherwise, from peg to aux peg, you move the disk using to peg as the auxiliary. See, from peg to aux peg using to peg as the auxiliary. Then if one disk means if one from peg to peg using aux peg, then disk n minus 1 from aux peg to peg from B to C using from peg as the auxiliary peg. Now I know that this concept is little bit confusing for now, but you practice the thing, then you will be able to understand, and these things will go on easy. Okay. Now let's see the problem. I think you have understood the algorithm. Now see, here I have just written these things. Here is the problem. See, here I have taken start disk as the L, intermediate disk as the C, and destination disk as R. Okay. And this is start, intermediate, destination. I am calling like this. So here I have written the code according to the algorithm only. And see, this problem is for 5 disks, and it is giving the output like this. Okay. So thank you for today.